Okay, when you are looking at the domain of an expression, what you're looking at is the possible values or the variables for which an expression is defined. And you guys probably know this more along the line of it's the x values. It's the numbers that you can substitute in or plug in for x. It's just all the possible values for whatever your variables are for which a given expression is defined. Okay? We're not just using x's in this class, so you can't just think of it as your x values and range being your y values. Okay? But when you're looking at domain, there's a couple things that I want to point out about identifying domain. Okay, the first is if you take an expression and need to identify what its domain is. Okay, so if you just take an actual polynomial form and are asked to find its domain, the way that you would do that is you just test it. What values can you plug in for x here? Can you plug in negative numbers? Is there any restriction on any negative numbers you can plug in for x and still evaluate this? No. What about 0? Can x be a 0? Yeah. What about positive numbers? Yeah. Anytime there's no restriction on the domain, the way that you will identify that is just the symbol for all real numbers. Okay, so anytime you have a domain that is all real numbers, you need to be able to identify how to express this online. Okay, so there's a couple ways that you can express domains when they talk about the actual values that can be used for the x's. One you can enter it in inequality form. Inequality form would be the following. All real numbers would just be represented by the capital R. Okay, there's nothing else that you need to do because it's any number that's in the real number system can be used for that. Okay, in addition to the inequality form of identifying a domain, anytime you're looking for the possible values or representing the actual values that the domain could be, you can also use interval notation. Okay, so in interval notation, all real numbers has a lower limit of negative infinity, an upper limit of positive infinity, and neither of those can actually be attained. So this would be your inequality notation. I'm sorry, your interval notation for this domain, all real numbers. Right now, what if there's another type of equation or expression that places restrictions on domains? And that's formulas, especially geometric formulas. The reason for that is when you look at this value, this radius r, can r be a negative number? Can you have a negative radius in a circle? No. Can the radius of a circle be 0? No, because otherwise it wouldn't exist. So you do have a restriction on the domain. So the way that you would represent this is r can be all real numbers as long as r is greater than 0. Again, it can't be equal to it. It can't be a negative. It has to be a positive number. So again, if you were entering or writing an answer to a test or quiz by hand, this is what you would write. If you wanted to express it online, the way you would do this is, again, you can do inequality form or interval notation. Inequality form begins with all real numbers, and then you just copy that inequality form. R is greater than 0. Mike, question?
So is the goal to have the expression not be negative?
Not well in the area. It all depends on the formulas, right? So if you're doing temperature, you can deal with negatives unless you're doing the absolute temperatures or whatever, or so when you're looking at certain things, it's restrictions that are based on the formula that's given. And so distances and measurements can't be negative, but temperatures can. So it all depends on what the formula is for. Now, if this would be the inequality form, you can also enter this answer in interval notation. The lower limit was 0, the upper limit infinity. You can never reach infinity. Here the 0 is not included, so it also would have a parentheses. So either of those forms would be fine for that online version of the domain. Right, one more type of restriction that we've already talked about would exist in an even indexed radical. So what do you know about the values that are inside the even indexed radical? They can never be negative. So when you take and identify the domain for this, you first have to find what values would make this a negative and restrict those. So if we take our expression 2x plus 1, we know that that quantity has to be a non-negative, meaning greater than or equal to 0. And so you could then solve for this. Any of these types of problems, if I give them to you, even though we haven't really done equation solving and inequality solving, they're all going to be linear form, so I'm guessing you've had experience solving a linear inequality. Okay, and you just solve for x, subtract a 1 from both sides, divide by 2, you get x is greater than or equal to negative 1/2. And so now when you identify your domain here, you're looking at all real numbers. Here, x has to be greater than or equal to negative 1/2. Okay. So the entry for this online is slightly different. You do need to take into consideration your answer could be in inequality form. All real numbers, x greater than equal to negative 1/2. So that would be your inequality form. You can also write your answer in interval notation. Your lower limit is negative 1/2. Your upper limit, again, infinity. Infinity can never be reached. Negative 1/2 is actually included, so you'll have a bracket around that. Okay. So these are the types of, this is the domain for expressions that we've already dealt with. We've dealt with polynomials, we've dealt with radicals. And again, this is only for even indexed radicals. I want to talk about the domain for expressions that have variables in the denominator, so rational expressions. So if we looked at the following example, and we wanted to find the domain, and how to express it online. Right, when you're dealing with restrictions due to rational or fractions, rational expressions, the one thing that can never exist in a fraction is you can never divide by 0. Okay, so when you're looking at these fractions, you need to set the denominator equal to 0 and solve for all the values that would give you division by 0. And the easiest way to do that is just factor them. So if we looked at this denominator, we have difference of squares. So it factors into the sum and difference of the terms that are being squared, x and 2. So x plus 2x minus 2 are the factors. And so when you're actually restricting the domain, here instead of identifying the values that it is, you're going to label all real numbers with the exception of, so x does not equal the two values that would give you division by 0. So negative 2 and positive 2. So again, if you were entering this on a handwritten quiz or test, this is how you would define the domain here. All real numbers, x not equal to plus or minus 2. Okay, when you enter this online, it's very similar. You're going to say all real numbers, x not equal to. Now, there's no not equal to symbol. So the way that we're going to express that online is equal/equal. So everybody see how that kind of symbolizes the not equal to symbol? It's like a slash through the equal signs. Okay, so when you write your answers, you'll write x equal/equal, not equal to. And then when you write your exceptions or restrictions, you're going to write them from the lowest number to the highest number. So plus or minus 2, you're going to begin negative 2, comma 2. Okay, now, even though you could write your answers in interval notation when you're dealing with just specific exclusions is very confusing to look at. So we're going to leave it just in the inequality form when we're dealing with this. Right? In fact, it's probably easiest just to leave everything in equality form, but if it's a list of, or a set, interval set, you can put it in the interval notation too.